Welcome to tonight's SF-Bay ACM. We have a talk, Making Neural Content Meaningful and Truthful, by Dr. Boris Galitsky, author of 150 publications, 50 plus patents, and 6 books. So this is Wednesday, April 20th at SF-Bay ACM. So for some background on SF-Bay ACM, we were founded in 1957, promote the knowledge of modern computing. We want to create community, support networking and hiring. We have a $20 annual membership. For upcoming talks on our meetup, upcoming events on June, we have Edge AI-based flare monitoring to reduce global warming. I'll be the speaker of that. If you have questions, you can use the chat in Zoom. You can write up questions for the speaker. I'll be the moderator and I can ask the speaker the questions. Also, if you have technical issues or if you have announcements of data science or related jobs or other events that this audience might be interested in. So I'd like to introduce tonight's talk. It's a deep learning system, or a deep learning system like GPT-3 can be substantially improved for factual correctness. They're going to build a content improvement system to repair these errors. They'll use text mining to identify correct corresponding sentences, use syntactic and semantic generalization procedure adopted from content improvement tasks. Find the results can be substantially improved for factual correctness and meaningfulness. For some background on Boris, he's worked at many startups, as well as eBay and Oracle for over 25 years. His security-related technologies of document analysis contributed to the acquisition of Elastica by Semantic. He's also an architect of Intelligent Bots project at Oracle, published the book Developing Enterprise Chatbots, and a 2-volume monograph, AI for CRM, based on the Oracle Digital Assistant. He's also an Apache committer to OpenNLP and created the OpenNLP.Similarity component. And now our speaker begins. Everybody, please welcome Boris. And if we were in person, this would be a good time to applause.
Good evening and welcome to the talk. So making neural content meaningful and truthful. There is a lot of news and discussion and buzz recently over the last couple of years about content generation using language models. The purpose of this talk is to first to show that the language model not really enough, and we need to do something on top of it to make it meaningful and truthful. And the metaphor I'm using here is the emperor's new clothes, naked king. So we have the king and we have the mirror. So like there's a lot of excitement about how deep learning and how language models can invent stuff, generate code, generate music, generate poetry. However, there's a lot of exaggeration in terms of usability. So this project addresses this is a problem, and let's see what it is in reality and what we can do about it. The plan here is I will first talk about motivation, why it is necessary to do something on top of what GPT-3 is doing, what language model is doing, how to identify wrong values, how to substitute them, why advanced syntactic and semantic means semantic structural representation is necessary to do that, how to apply fact-checking, or do this content improvement at the discourse level, open source representation. And his example of long critique of deep learning in general and language models Marcus, some example of what GPT-3 is generating. It starts with like small dinner party. This is where we are. Its first sentence is okay, sentence is okay, living room, then remove the door, table, so totally, this is abrupt switch, and we switch to totally different. And that is exactly what we don't want in our resultant content. And we will explore ways what we can do about it and how we can fix it. But this is example from technology review paper of Marcus, and that's kind of a typical situation. What we see here, grammar is acceptable, sentences are properly formulated, discourse is kind of okay, there is a links, like logical links between previous and following sentences, but then second, third is neutral, but then finally it becomes totally meaningless. Like why, once we talk about table saw, the content is ruined. So objective, we take typical meaningless raw content. We call it raw content, content obtained by a language model, and crossbreed it with content taken piece by piece from various trusted sources, so that each sentence its source is not necessarily original, but definitely truthful. So we borrow structure and content flow from what is invented by GPT-3, and we take the facts from text mind for depending on different applications. It can be from the web, from the internet, from specific corpus. And again, I think this is a good time to stop for short Q&A. Like, would the audience agree with me? Like, any anecdotal experience, how people like experiments with GPT-3? People tried, people like, didn't like. What are the feedback on motivations? Yeah, Greg, maybe there are questions from the audience.
I'm viewing now. There are no questions yet. I'll speak up when there are.
Okay, so if there are, then interrupt and we can continue. So, okay, now about the content. So content generation is a big, long term goal of AI. And before GPT-3, I spent a lot of time personally in different commercial projects, writing, convincing Google that this is original content, mostly for search engine optimization. So as long as search engine doesn't understand that this is artificial content, this is good enough, and usually not for human. But GPT-3 is really a breakthrough, so it is designed for human consumption. Now a little bit from the machine learning. So I'm kind of obvious what is prediction done by learning. We have some training cases. Now we have new case. We find some similarity with previous history. We apply this similarity and predict. So this is a like foundation of machine learning, and deep learning does pretty much the same. For content, writing means we have a starting idea. Then we maintain in language model similar sentences, and then we combine them, trying to average through them. When we do this averaging, the idea we actually can do in inventing, because we can averaging old ideas can bring to inventing new ideas. However, obviously we cannot guarantee values. When we averaging, we break, like one text about banana, another text about apple, we average, it gets some random fruit, and then we get the fruit name, but other words, modifiers for this noun fruit, would not be truthful anymore. And this is kind of natural. So I think by internal means of transformers, it's kind of intuitive. We cannot really get truthful text. So for truthful text, we need to get additional knowledge source. So all knowledge encoded, captured by language model, definitely not enough to combine truthful text. What I refer here, a good way to think about content generation is still nearest neighbor. As we add word by word, we consider neighbors. We switch from neighbor to neighbor, neighboring similar sentences. And it's kind of proven that in terms of deep learning implementation, it's still gradient descent is a kernel machine. So this intuition can be applied. So here enumerating, there's a lot of different applications of GPT-3, a lot of code generation. And I don't comment on how, in code generation, you have to be truthful. Let's focus on text, like with stuff like poetry, charade games, talking head. We don't have to deal. Sometimes tolerance to deviation from factual and stuff and truth can be tolerated. And here's the site of, again, a broader variety of applications of GPT-3, of ad generation, design, writing all kinds of book writing, chatbots, explanation, generation, code stuff related to code. So again, to code, probably it's still interactive. So system generate code and humans still edits it. So again, errors and factual problems are acceptable. So for blog writing and like social writing, it's this is probably the focus of application of this technique because truth need to be fixed, and it still has to be meaningful. Again, we propose a way of making arbitrary, grammatically proper content truthful and meaningful by substituting whatever needs to be substituted. And again, we have two sources. Generated content generated by GPT-3 we call raw content, and factoids from the web, from internet, from trusted sources, from knowledge ontology is a true text. And then how to just why do we need web mining? How to obtain true sentences? We take a raw sentence, we extract noun phrases, other significant phrases, we build OR query, search again the whole web, Wikipedia, internet, specific index, and then select sentences which are the closest to generated. And then we do this crossbreeding. And again, I'll try to come back to this idea that we combine, merge two sources. Some nice features we get from GPT-3. The rest of the features, and particularly the truth, we get from complementary content which is complementary to generated by GPT. So what we get aware? Sources of text we again generate by deep learning and update from sources on the web. Syntactic flow we try as much as possible take from generated because it helps us with originality and with ideas. And only if required we take it from true sentences. Discourse flow, as long as it's truthful and meaningful, we can use it from GPT-3.
And just to describe for the audience, the discourse is over multiple sentences as opposed to within a sentence, is kind of define the term of discourse, if that helps.
Okay, so discourse, so we have syntactic, semantic, and discourse levels of analysis. And Discourse is usually how author organize thoughts independently of what is the subject matter. It doesn't matter if I talk about biology or physics, the way I deal with entities, I organize my sentences, I combine my sentences and entities propagate the sentences. This is called discourse. And again, for content generation, we have to maintain syntactic and semantic, but also discourse cannot be random. Let's go to logical flow. Again, we try to get it from GPT-3. It could be random, but as long as values are correct, the overall reader impression is positive. And so original idea, that's the main thing we get from GPT-3. And once original idea starts deviating, like our table saw example, then we start getting it from true sentences. But again, our preference is for generated sentences. So entities, most entities we try to get as many from raw, but we substitute them if necessary. So from true sentences, we get correct sentences. And for example, we start with, we need operation of alignment. So how do we know what to get from what? We take raw sentence, we take true sentence. In this case, with the red, we show what it needs to be substituted. And with green, what is synonyms or different phrasing. Those green stuff can be retained in raw, and red stuff needs to be substituted. Let me also need to be substituted. So let's now focus on correcting how we correcting the lie. Let's talk about poetry. And in this example, we start with our seed is Russian poet Pushkin. Pushkin wrote provincial chapter of Evgeny Onegin. And then we want GPT-3 to continue. This first sentence is perfect. GPT-3 in language model, there are there are obviously some content about Pushkin time writers. So Pushkin sent letters to these other well-known writers. So this is correct so far. However, the second sentence, so idea is there is a certain St. Petersburg, and it is truly associated with Pushkin, was approached for some person who wanted Pushkin to become translator of German edition of his poems. Turned out, this is a total lie. What can we do about it? So we want to find that Pushkin translator, a person who associated with translation of Pushkin into other languages. So it turns out that almost everything is wrong in this sentence, other than main idea that there was a translation to other language. So it turns out that this person, Rodion Romanovich Kraft, is a fake. It doesn't exist. Again, we check it by going to the web and searching for this exact phrase, like who wanted Pushkin to become translator. And what we figure out that in real life, it was not this fake person, Rodion Romanovich Kraft, but instead actual writer Nabokov. and then he translated not in German, but into English. And then it was different century, different location. So a lot of stuff have to be either cleaned, removed, or substituted, but the idea stays. So instead of this fake part generated by GPT-3, we substitute the result which we found on the web in this yellow. It's totally different year. It's not wasn't really approached because Pushkin was long dead by then. He is the writer who holds he's a giant of both Russian and English literature. He published English translation of Pushkin's masterpiece. So see, this is the closest possible factual sentence found on the web, closest to what GPT-3 is composed. So once we substitute this craft sentence with this sentence, we are good. For other examples, we also need to verify that other next following sentence entities are correct and properly associated with this sentence, but at least this is a good example. To summarize, there is a main entity Pushkin, which is properly retained in GPT-3. There is an idea about translation into foreign language, which we keep. So this idea is a nice and logical as a third sentence. The problem is, again, wrong person name, wrong language, wrong date, and wrong location. So all the wrong parameters and values we substitute, and whatever is correct, whatever is acceptable, we don't have to retain. Okay. So now let's consider first alignment and a similar example from healthcare. Now let's maybe not go too much into details, but instead let's look at how alignment works. So what is semantic and syntactic representation and how they are mapped into each other? So what we see here, there are two sentences. And again, this is in this case, it's not, I use this example, it's like under-educated doctor and professional doctor opinion, and how we can fix one by another. On the top, we have sentence, she has potassium depletion. Spironolactone is a potassium-sparing drug that will cause her to retain potassium. So we have a semantic representation here. This is called AMR, abstract meaning representation parser. Gives that we start with end and cause. And instead of coding, so nodes here are not really words, but instead main entities and the relationship between entities. So below we see it's using Stanford NLP, Stanford Natural Language Representation. This is a syntactic representation. So there's an obvious map between syntactic representation and semantic representation. She and she. Potassium and potassium. This is obvious. What is not obvious, the relationship now between like raw sentence and true sentence in semantic representation. So green nodes show mapping between entities which are mapped, and red means this is mapping which are corrected. Again, syntactic is mapped into semantic in both cases. And then we have mapping between semantic representation, and for each node we decide we retain it, confirm it, or substitute it. So again, in this diagram on the right, we have syntactic level for two sentences, semantic level for both sentences, and then mapping. And this whole thing we call syntactic and semantic alignment, because to substitute proper values, we first need to align sentences. And again, both syntactic and semantic information is used. Then we have a mapping. And then if mapping is between the same entities, we retain it. If mapping between different entities, then we take true source on the bottom and substitute into raw source on the top. And again, in this example, this is not a raw content, like auto-generated content and content mined from the web. This specific example, it's like under-educated doctor and doctor, authority doctor. So what is on the bottom substitutes and annihilates what is on the top. And again, to do this annihilation, to do entity substitution, we need syntactic and semantic alignment.
So just to get to a more fundamental level, can you go back to that slide?
Sure. Mm-hmm.
So Stanford NLP was for the syntax parsing.
Okay, Stanford NLP gives syntactic representation.
Right.
Then this called AMR parser. These days, deep learning based on core specifically annotated corpus, where we have like different works of literature annotated with the semantic representation. And we need both levels because some information is not retained on semantic level. So we need both levels. I was going to ask,
what is the tool used for the semantic tree generation? The semantic parsing.
It's called AMR parser. There are parser in Python. So if you called AMR lib.
Okay.
So if you just look on the
Python library then?
Yeah. So there is a deep learning parser in Java, but it's not as reliable. So if on GitHub you just search for abstract meaning representation parser, you got some options, but in my opinion, the best these days, the best is deep learning based AMR lib.
Okay.
However, I mean, the real life is, because it is deep learning, it also can be random. So for short sentences, it is reliable. But for longer sentences, it's not just does wrong part of speech and wrong connection. It actually invents like some terms and some words, which is not usually like, that's like deep learning style. So we have to be ready to handle some unpredictable and random stuff. That's just how it works these days. But nevertheless, it's relatively efficient and reliable. I mean, reliable in terms of it doesn't crash. Parser, again, AMR lib. Okay. So for whatever semantic task, these days you start with it and then see the results and observe if it's overkill or not. So it's pretty like a tool. You can extract entities, you know what are the names. So it does a lot of work for you versus doing reliable and pretty much like everyday use the syntactic parser and then try to build a semantic analysis yourself. Okay. So again, using AMR parser still like first choice to try and see.
Sure. And then the tool to do the correction of the semantic trees, was that another open source tool, or was that what you developed?
It's I developed. So, okay. So syntactic mapping, I spent many years, and this is my contribution to OpenNLP. And that is work pretty reliably. This is useful, for example, for search application. If think of it, this question on the top, answer on the bottom, and you want to find syntactic similarity in terms of parse tree. That works pretty reliably in Java in the project I have in this PowerPoint link. So if you just search for my name or search for relevance based on parse trees, you'll get to this project. But semantic level for AMR, it's not a public code. This is a code like being developed. So there's no reliable way yet to do alignment of semantic representations. That's a recent work. So now let's move on to other example and focus on fact checking. So now let's try different genre. Let's try generate biography. And what we see here is style is retained. GPT-3 does a good job at biography style. However, the values are wrong here. And what we show here, values which needs to be substituted shown in red, and true sentences are highlighted in yellow. And again, the values that update values in raw sentences are shown in blue. So what do we see here? Year is incorrect. So instead of 1894, it should be 1946. A lot of style. There's no aphorism. This is kind of it is a domain. It's a properly remaining. It properly belong to this domain caring for the baby, but it just never happened. So again, for each sentence, we kind of rewriting the biography, trying to be truthful. So Dr. Spock did not found this school. Instead, he was an official founder of intuitive and attachment parenting. So we get kind of idea, like we have entity person, entity what can a person found. We try to get this idea, what did Spock found? It turns out that he didn't found the school, but instead he founded a concept. Was born totally different date, totally different place. His father was not a physician, but was an attorney. And practicing, doesn't have information about the mother, at least not in this sentence mind on the web. And he was working in particular state and so forth. So again, what do? We take each sentence and we do fact checking. Facts which are confirmed stay. Facts which needs to be substituted, identified and substituted by means of alignment. Similar application for the drug. So why do we use a medical domain here? Idea was, obviously this is medical domain is serious, and we cannot really trust this procedure because probably we will not be able to make it 100% truthful. However, the idea, if we do our best to get the highest accuracy for this medical domain, then for other less responsible domain like social promotion, blogging, we can satisfy, we can have some error rate, but nevertheless satisfy the user. So that was motivation to try it in medical domain. Yes, sure.
So the red text is what needs to be corrected. Is done by an external labeling service or you manually?
Oh, no, it's automated. Also, so I'm showing that it's all supposed to be automated. Okay, how it is done? We take, let's go back. We take best known for aphorism, whatever. This is what GPT-3, what we do, we take the simple case, we just take this whole phrase, go to Google and run it. And it turns out that there is no such aphorism. So Google is unable to find any sentence similar. There's nothing on the web found by Google if you have to care for a baby, feed it for 2 years. That's total invention of GPT-3. It's actually nice because for pediatrician, it's a very domain relevant. It just doesn't fit biography style. Because in biography, we have to be truthful. So we have to remove this whole red stuff. And for arbitrary, for example, if I want to write my fake resume that I'm a pediatrician, that would be good, but just not for biography. And again, how do we do fact checking? We try to find the whole sentence. We don't find. Then we extract noun phrase, keep trying, search on the Google. And then if we don't find anything, we say, okay, this sentence probably it's nothing totally fake and acceptable. If we find parts of it, then we substitute from yellow stuff. Yellow stuff is what we found on the web by searching the sentence on the top. And then we see that Spock was the founder, we confirm by webmoney. There is some document on the web saying that Spock was the founder. It's just that on the web, we figure out that it didn't found New York school. It found the concept of intuitive and attachment parenting. Did I answer? Like, is it clear?
Yes.
Like in human, so like, okay, I have an injury. How do I, like, first thing I go to Google and check, what do I do and now instead of having a real world situation where I go to Google and ask, what should I do? I take what GPT-3 gave me. I don't know what to trust. So just in case, whatever GPT-3 gave me, I go to Google and verify. So this is the idea. And this can be automated, right? Because in real life, I go to Bing, I use Bing search engine API, and then I compare whatever I found on Bing, I apply syntactic and semantic alignment to verify, accept or reject. More questions on this?
None from the chat window.
Okay. Okay, so again, how web mining works. So I have this search query, and then how to treat this. Again, that's a medical domain, and then stuff in the red showing no, it's not. Can I use lamotrigine for treating depression? Turns out yes, it's a mood stabilizer medication, so I can use. That's confirmation. Can I use? Does lamotrigine target benzodiazepine receptors? No, it doesn't, because it targets different receptor. Lamotrigine side effects are similar to other TCAs. Yes. Tricyclic antidepressant. Yes, they have similar effects. So see, each phrase, I have auto-generated text. I extract each phrase, and then I verify validity of each phrase going to the web. So if I search result, if this sentence can be aligned with the query, it means it means in general it is approved. Maybe some values are wrong, but in general, at least, there's something similar on the web. And in the red case, it means it's just.
Do you do anything to exclude bad sites that may be intentionally fake news, or like The Onion, something that's parody or type of content? I mean, when you're doing your search, do you constrain what your search?
So I'm trying to. Here in biological domain, Google just, if I'm asking something related to healthy, Google does not give me like fake. It gives me nature.com. It gives me like WebMD. It gives me reasonable site. So in general, I think search engines do a good job. And if my queries like domains like legal domain or medical domain, then it does a good job. For biography, I limit Google search to Wikipedia. So you, for example, easy way, if it's factual, you limit to Wikipedia. If it's related to shopping, I use eBay search engine API to like stay and identify products. And then it's the same thing, fake products, real products, fake attributes of products or real attributes of products. So this is just like have reliable website and just one step in this whole trying to maintain like reasonable sources you can trust. Okay, so let me spend some time describing what is a discourse representation, discourse tree. This example in medical domain, we now look at indentation. So discourse tree is a tree represent where text is split in so-called elementary discourse units, and there are hierarchical relationship between these units. And this tree is shown by indentation. So it starts with means, and then we have two parts. Elaboration is a default relation, like additional portion of text just provides more details. Means that one text explain what are the means to achieve what is part. Comparison means we have two parts of text, and one bottom part then is compares with the top part. Contrast means there is a disagreement. So something, but something else, and so forth. And again, the structure is hierarchical. So on the top, we have original text generated by GPT-3, which is basically medically wrong. And once we substituted entities, in addition to correct entities, we also want to maintain proper discourse. However, the discourse is combined by a language model pretty well because it's a huge corpus it used to train from. So when we do entity substitution, we just care about individual word or individual phrase. So what we do here, we maintain the mapping. We looked at syntactic mapping and semantic mapping. And now in red, this is discourse mapping. What it does, it maps corresponding discourse relation. Contrast is mapped to comparison. Enablement is mapped to enablement. And cause is mapped into contrast. What we want to see here, that by substitution, by the procedure, we syntactic and semantic level, we extend the text. But now what we're verifying that this overall text has similar discourse structure to the raw text generated by GPT-3. So this is what we're doing here. Again, semantic and syntactic level, we do after web mining to verify each entity. Once this is done, we'll have a higher level look. Did we do proper at the discourse level? Let's build discourse tree of original raw text, and we trust GPT-3 that this is like readable and proper overall logic. And then we map it into discourse tree of like merged, crossbred text with improved values. And then we check that the discourse representation is properly maintained. Because if not, although entities are right, but still unreadable. So if not, we have to go back and try different substitution from different sources. So in the high level algorithm, we first try to do as much as we can to make it truthful, and then see if current substitution maintains proper discourse. If not, we go back and say, okay, let's try to find other sentences, similar sentences, substitute with different values, with different discourse. Maybe second time we have a better luck, and our mapping would be more accurate, cover more the whole tree.
So do you end up with a numeric score that's evaluating it? Because you say, try one kind of mapping. If that doesn't work, go back to another. So are you
basically the score is proportion. Okay, so talking about the score, it's proportion of non-trivial rhetorical relations here shown in bold. So we have to address, so-called address each rhetorical relation in raw text with the one in resultant text. And if not, means we missed something. We repaired wrong values, but we broke the discourse. So the overall logic is broken now. So to maintain that it's not broken, we need to be able to map most rhetorical relations to those in corrected text.
So you're trusting that the GPT is a good structure.
Yeah, in this case, yes. And I mean, not much we can do about it. If even a regional GPT structure is not good, then we cannot improve it. That's a part of this work. I might have time just to mention it, but the short answer that I'm not trying to improve it. The reason it's usually good because once you average, when you average through millions of texts, your values, averaged values, are wrong, but your like high level representation is acceptable.
Okay, so the strength of
Because
GPT
you average to so many different texts. Then once you again, so the text level and multi-sentence level, your averaging gives pretty smooth, which is a discourse level. However, individual values are wrong, so you have to repair them.
Okay.
And hopefully by repair individual values, you don't break this whole logical flow of text. And if you break, you have to do it value substitution again from different sources, different values, pretty much different ideas.
So in a way, GPT is read millions of documents. It's got good structure, but lousy fact checking, and you're adding the fact checking.
Yes,
it's kind of like a baby babbling. Not past the babbling stage, starting to generate sentences. The sentences don't make sense, but you're correcting the parts of the sentences that don't make sense.
Yeah, exactly. That's a good high-level view on this part. Yes, that is what he's doing. Okay, so looking at the implementation, these are the steps. For each sentence, we go sentence by sentence, determine if it's potentially acceptable, form a search query, and then try to release, like simplify search query one by one till it fires, till we have similar results which we can align. We get candidate true sentence. We align a raw sentence with each candidate true sentence, determine if it can be used. Sometimes we can skip sentence, but if you skip too many, then we break discourse. If yes, we decide yes, it's acceptable. Now we can substitute it. And it's sufficient, it can be sufficient to substitute entities or insufficient. We perform substitution or find syntactically matching and semantically closest true sentence candidate. And we verify the agreement in this sentence and other sentences, and see what we saw the last slide, deviation, assess deviation in the discourse structure, and finally output for each sentence, and then we merge them. So these are sentence-based, step-by-step procedure for making it truthful. What I should mention that the author, the GPT-3 team, they obviously observed this limitation, and they also tried to automatically learn. So what can be done by GPT-3 and what can be done from the web. But if you look at their demo, they ended up just taking sentences from the web and not using. So once they combine GPT-3 raw and true sources by learning, not by trying to manually handpick values to substitute, then this whole system converges to just getting text from the web. So it is truthful, but not original. This is not what we want. Okay, maybe questions about this comparison. Because this is important to.
So your objective is to not copy things off the web, but try and generate new content.
Exactly, because if you copy from the web, why do we need GPT-3? Why do we don't need language model?
So what is it you're giving GPT to get it to generalize? And I wonder, like sometimes if you do transfer learning in vision, you take a competition model that's trained on 1,000 objects, and then you specialize on the 30 you need for your project. And
Okay.
you might freeze the lower weights and train just the last output to save all the past convolutions. Is there something similar to convolution learning you could do with GPT to have it do better? Like if you're doing something on a particular subject domain, then just start with initial GPT-3 and then do some kind of transfer learning in the domain you care about. Like you had it earlier, medical domain.
Okay,
And
this is a
maybe if
very
you give it more
critical.
training on that, can it get a little bit more factually realistic, a little bit more discourse realistic? I'm just wondering if that could be part of why does that not work? And again, I'm not an
Okay,
expert on GPT-3.
you raised a very important point, and what I'm claiming is you cannot substitute knowledge acquisition by learning. Learning is generalization. You learn the general laws of something. You cannot acquire individual facts by learning.
No,
That is why.
I'm not saying replace your work. I'm saying if this was going to be a project in production, complement the work you're doing, giving you better original sources, from GPT. So do work at because you're doing error correction on GPT-3. So what I'm proposing as more of a brainstorm level, I haven't thought through, is keep the same structure, keep your improvements, your searching Wikipedia or the appropriate sources, but just in addition, do some additional transfer learning on the GPT itself to the domain you care about.
I understand. Okay, so the point I'm trying to make, these days it's extremely popular to learn everything and claim that language model doesn't only learn language, but learn also facts. That is why I'm saying, no, you cannot do transfer learning. The brief answer, you cannot improve GPT-3 because GPT-3 is already a huge corpus. When you get even a bigger corpus, you have a better coverage. So you can generate content for a new domain, like specific, medical, very specific medical disease, a very specific drug. However, it's not going to be more truthful. As you get more data, not going to be more truthful, just better coverage in some domains. So you cannot substitute dealing with exact facts by learning. It's a complementary task. However, a lot of people believe, especially like OpenAI community, OpenAI, they believe that they can achieve everything by learning. And this is where we disagree. So transfer learning, not for this. You cannot improve GPT-3. I think it's always, if you just get one thing from GPT-3 and you get other thing from ontology, from web, from whatever. But this is two totally different sources and you cannot substitute one by another. Like, for example, at some point, like 20 years ago, it was very popular, like pure ontology approach. Once you build excellent ontology, you don't need anything else. You can generate text. These days, opposite approach is very popular. You take huge amount, you take huge corpus, and then you learn it. And then once you have huge enough corpus, you can learn everything, including facts. And I'm saying, no, you can learn language, but not facts. Facts, you still have to get outside.
I understand your position. Although I will have to tease you on the statement, you can't improve GPT-3. I'll have to call you up in 3 years and ask you about GPT-5 if it's better than GPT-3.
But I try to explain, it is better
No, I understand.
but not untruthful. Very interesting. If we come back to this, and if somehow, I don't believe, but if it's possible, then from language model, you can also have a perfect fact checking inside. I would say I was wrong. I would confirm.
No, I do see the role
Very
about doing better
interesting.
fact
Very
checking.
interesting
Yeah,
to
that
see.
certainly makes sense because if it doesn't have a very rich Wikipedia-like structure on what facts are in the right structure, I do see how GPT is better at the language model, but not the facts. So you've made a good case for that.
Okay, what are we doing on time?
Let's see, it's 8 o'clock. Half hour is comfortable, a little bit longer if you
Oh,
want.
I do less, my less. I'm
That's
just
fine.
going to do a brief evaluation. So what we evaluate here, again, we do a medical domain, not because I truly believe that it can like help in it's too risky. However, just why don't try and see and measure performance, and again, then try simple domain. So try to do it in the hardest domain, and then see if users can accept it in a simple domain. So the application here is a personalized drug recommendation. Why do you need generate content? Because we have a drug description, and then we have 1,000 of different syndromes, symptoms, and patient conditions. So you have to adjust. So for this case, you actually have to generate. I mean, either human doctor has to write, or you need to automatically generate. This is a situation when you do need for combination of drug and condition many different texts for different drugs. And here I have classes of symptoms, and now actual measurement of percent of numbers and percentages of generate of wrongs of sentences which needs to be corrected from text. Texts are usually short. It's like 3, 4, 5 sentences. It's a brief recommendation, like take these drugs, then look at these side effects. So we substitute entities. We separately measure substituting entities and phrases. Some sentences we reject, and then accept total number of raw sentences and true sentences used. Sometimes we use many, and then it is reduced. Overall, we have, so it's more than twice as many true sentences we need. And then we measure the error rate of repaired content. The same disease, we measure differently by generating like drug recommendation for different diseases, a rate of wrong facts per raw content, wrong facts corrected content. See, this is still relatively high. So again, not acceptable for healthcare domain, but hopefully like for some social promotion, like blogging, and especially opinionated data, when you cannot lie, but you can have kind of opinion, much stronger deviation in opinion is acceptable. A rate of wrong facts per sentence for corrected content. So what we get as a result? So only 6% of raw text can be accepted without repair. And after correction, 84, see, it's still not 100 of text do not contain wrong facts. 70%, 70% of wrong facts in raw text reduce less than 7% by this correction procedure. And then there is an ablation study. What we do, we remove some system components we described. Then we have also apply manual assessment, reduced simplify web mining to smaller site, to smaller domain to see how it affects. Then instead of using syntactic analysis, using keyword-based generalization, do not substitute individual phrases. And then we see that there is a certain deterioration of accuracy. So once we simplify each component, we just pretty much the portion of factual errors, the rate of errors going up. So it turns out we do need these linguistic tools, and cannot simplify linguistic processing to keyword-based or significantly simplify web mining and hope that we can still achieve that rate of correctness. So I really quickly ran through this project done by our PhD student. That is more traditional, so learning within learning. How to actually try to improve discourse, but not by external means, but instead trying to build a training data set using these discourse trees, and then using this training data set improve GPT-3 discourse, trying to classify discourse trees. So this is a different visualization of discourse trees. The same thing. So this is text. This is hierarchical structure, top level rhetorical relation of elaboration, lower levels. Then we have specific relations of contrast and condition. We build these discourse trees, we learn them, we do discourse parsing, we annotate and try automatically when we generate using GPT-3, we additionally train to try to have proper discourse trees as a result and avoid improper. But this is not working well. So we tried it, but pretty much the idea is using this approach, we can differentiate fake text from actual text by discourse tree, but we cannot really improve to make it more readable. No, so this was a useful exercise, try to improve GPT-3 from inside using discourse analysis, but it's not working well. Okay, just also mention this is a part of OpenNLP.Similarity project. You can find it just searching either by my name or relevance based on parse trees. And here I enumerate some features. So there's a lot of stuff inside you, and the idea you don't have to get into linguistics if you want to do syntactic similarity. You just pass two texts and everything else is under the hood. System will build representation, build syntactic representation, semantic, go to discourse level, assess similarity, and just gives you a score. And then you see if it's good for your applications like recommendation and search, and you don't have to go deep into linguistics. This is in Java. Okay, conclusion. So tool is correcting entity values to construct meaningful text. The claim here, if values are wrong, although the grammar is correct, with wrong values, text is not meaningful. And it works on top of neural content generation, but it doesn't have to be GPT-3, it can be the language model. Okay, I think this is a good time to stop. And this is a link to the Python project for content generation, building Google Documents from text. So you give it a seed, it builds Google Doc with images, links to videos, some product description, opinionated content based on the seed.
Okay. So there, in
the
Q&A section, there are some questions.
Okay.
So Carl Anderson asks, do you need a parameter for fiction versus fact? So quotes and dates versus creative writing. How many words need to match? Paraphrase is mostly fact. Mad libs could be anything syntactically.
Okay, so again, this is solved. So I don't have numeric measure. I have syntactic and semantic representation of raw, and then everything needs to be corrected. I'm not saying let's try to correct some portion to maintain the proper grammar and proper discourse. I'm not saying that. I'm saying let's correct 100%, and then if it's overall we broke too much, we broke the grammar, we broke the discourse, then just try to recorrect from different sources. But we don't have this optimal ratio between let's correct 30% and keep 70% so we don't break too much.
Well, I think his point is if the text being generated, if the objective of it is to be something factual, like medicine,
yes,
versus fiction. Let's say you're writing a story that's not intended to be factually true, and you're writing your own story. Maybe the setting isn't on planet Earth.
Okay, I think for stories, so if it's like for computer games, you just don't do correction. Because original, we don't need to correct grammar. For stories, maybe we don't need to do correction. What we need to do, just do some discourse assessment. Because even for games, sometimes, like starting from sentence 4, 5, 6, it's totally off. So we just remove those cases and regenerate. But in general,
like your first example had, look at the picture, there's a table, and then it got into, oh, their door's too small, and then you have to cut the door with a saw.
Yeah.
So even if you're generating fiction, you're going down a path that's not useful.
Yeah, this is wrong. So basically what we do here.
So you could be generating a fiction story here, but it would benefit from correction by not going down this path of why the heck are you focusing on a saw to cut the table when have the story be more about the people or something.
Okay, agreed. So here, what we do, so in this approach, I don't try to like do optimization. I try to either don't touch it, and there's a different problem, or substitute all possible values. So I have to go to the web and substitute everything. And I'm not going, if I have the context of dinner party, I'm not going to have a table saw. So I will substitute table saw with some table game, for example, because table game is good for dinner party, but not table saw.
Okay.
And again, I will try to substitute as much as possible to be truthful.
Sure.
I'm not going to say, let's limit substitution just for whatever, for some optimal. I'm trying to take each sentence and confirm or reject each sentence by the meaning.
Okay. And then another question that came later from Carl Anderson, comment. Wikipedia has several different categories for sourcing. So like medRS for medical articles have a higher criteria. So I think he was just pointing out sources might have different quality.
Okay, so I didn't experiment with quality. That's like a little bit, that's maybe future work or extension. So for medical, I go to particular, like there is a drug recommendation, WebMD, and there are a few sites I limited the Bing search to. And fact checking, I'm not, again, it's a very, like my personal opinion about fact checking and something which is very popular today is different. Today, still fact checking is done based on learning. And for me, I have a big problem with that. I have difficulty. I mean, I cannot agree with that. Because
I don't think he was making any statements of that. I think he was just saying that there's, if you're doing your fact checking, he said Wikipedia has several different categories for sourcing. And then he said WP:/medRS for medical articles have a higher criteria. So I was just thinking he was saying if you are directing towards your fact checking.
That would be better. Okay, probably other sources.
Okay.
So for this work, I'm not really like, I didn't try because okay, so if I have a little bit, if error rate were 10% and I could improve it by like from 90% to 98%, then having better source is important. But since I'm trying to boost like from 20% to 90% to 80%,
sure,
then I have other problems to worry about
than
sources which are not very reliable. However, for real medical application, that is essential. just for purpose of my experimentation, that is not critical, because again, I was doing from 80, my goal start from like 20% and get
Sure.
to 80% versus from 95 to 98, where this knowledge would be really critical.
Okay. And then Paul had a question. Is the fact checking you developed the best available? And he's got several comments. I'll read them all and I can go back if you have questions. It seems like this might be the most valuable part of what you've done. It seems like there could be many other applications of that. Using it to get GPT-3 to generate factual text still leaves the impression that GPT-3 and even the combined system doesn't even really know what it's talking about. So there's several questions. Maybe I'll just start with the first one. Is the fact checking you developed the best available?
I'm not claiming that. I'm not claiming that. It's best for the context, best. I mean, I'm not saying best. I don't. Okay, so today there is a competition in fact checking, and this competition is done still via pure learning, pure language model, and I kind of disagree with the concept. So I'm not claiming at all that it is the best. So whatever is officially the best today, I cannot. It doesn't fit my.
You have an approach you like to envelop, and you like to approach and research in a certain direction. So that's the direction that you're focusing.
I cannot understand how fact checking can be done via learning, because learning is generalization from facts, and checking, fact checking is individual fact obtained from some of. So to me, it's incompatible. However, like official competition and officially best available are deep learning based.
Yeah,
that is why I kind of refuse to compare, because that's totally different flavor.
And then the last part of Paul's comment was using fact checking to get GPT-3 to generate factual text leaves the impression that GPT-3 and even the combined resultant system doesn't really know what it's talking about.
I totally agree that GPT-3 doesn't know totally, again, because of learning, because of nearest neighbor, because of language model, it definitely does not know what it's talking. So I'm trying to add knowledge. I'm adding knowledge from not structured way, because there's no, there could be an alternative project where instead of mining the web, I would mine ontology. So in this case, what I'm doing also doesn't, in a strict sense, doesn't know what it's talking about. However, when you substitute values, it becomes like an informative kind of acceptable reading, especially in opinionated mode. But I definitely support this thing that from the higher level, from like logical, serious logical AI level, what we are doing, we don't really know what it is talking about. So I agree with this. That was the motivation of this work. And in general, so there are serious domains like legal, engineering, and medical that you do need, when you 100% need to know what you're talking about. And that is not for, I think content generation is not for that domain, not for these domains. So I totally agree that we kind of playing the game where we don't know what it's talking about. This whole like deep learning, right? This whole deep learning, like general learning and pure learning approach is not knowing, it's like playing, but not knowing what we're talking about. I think that's a good way to look at it.
Okay, and then this is more a comment from me, is there's a phrase, mental model, that people sometimes have. When they understand something, they have a good mental model. And so here in your picture, you see people with having dinner at a table. So would it make sense to improve upon the semantic trees by having things like, for some situations, maybe not every situation, a 3D scene that's a mental model of whatever system that would have a better understanding? You know, a mental model where it's building like a 3D environment, people are sitting in different places, you see the food on the table, you know, it's not 2D specific, since your mental model is of a 3D scenario, you have a 3D scenario. If it's a mental model of a scenario over time, then maybe you have like a video, only it's a 3D video of the state of things over time. And then if you were to build up something that's, focus on building the mental model to represent the structure of what's happening and the relationships. The relationships could be in a semantic tree, the relationships could be in a 3D structure that changes over time by frames. But if we were to have something like that, that seems like if we had a better mental model, we could have better, more understandable generation.
That's another thing of, for example, we start generating text about a party and imagine we have unlimited access to annotated videos. That's a great source. Instead of taking text, we can take videos, we can take like phrases, we can substitute. So think of this like video data as another good source of improving substituting values, just an additional source.
Right. Okay. Some other text came in on the chat. So Carl stated, classic puzzle. You're in a room with no doors or windows, just a mirror and a table. How do you get out? And then his answer, you look at the mirror and see what you saw. You take the saw and you cut it in half. 2 halves make a hole. Put the hole on the wall and climb out.
How can you generate this? I want to reiterate
that would be a good interesting thing to represent semantically. So, other questions from the audience?
Like, for example, in this text, I'm thinking how to confirm, how to do fact checking for this. Okay, I'm just thinking that's a cool example for fact checking.
Yeah, that would stump fact checking, I think.
Because fact checking, you can break. I will try to substitute. Then it will confuse so as a noun and so as a verb.
Well, that's the whole play on words, right?
2 halves make a whole, that will be confirmed.
The 2 halves make a whole.
Put the hole on the wall, it will not be confirmed. That will be it will not be confirmed. But that's a cool example for this. Yeah, that's a cool. I'm just curious how I can copy.
Okay, I can email it to you later. You can use that as a.
That's a cool.
Yeah, thank you, Carl.
That's a cool for fact checking. That's a good thing for fact checking.
Yeah. Okay.
And then there's a stochastic parrot.
So just last question, what are future directions, areas for improvement that you're working on this theme?
I think include each part.
Okay.
Improve, like GPT, going to be GPT-4.
Well, I mean, the things that you're working on. It sounds like
rely on Reacher, apply Reacher set, like I use Google, not only web mining, but Google. This is already done in this open source project. Use a Google Graph for confirmation, use more structured sources, integrate with ontology. That's a good, improve AMR parsing and hopefully AMR parsing. So basically combine from different components, third-party components, open source, and then rely on their improvement. So each part, syntactic parser is good enough, but other components which I use just rely on improved. I think the general algorithm, you have to substitute values. I don't think there's any other. I don't think you can do after training of GPT-3 and again, make it know what it's talking about. It's never going to happen. So you have to acquire facts from somewhere. So make richer sources, better sources.
Okay, very good. Well, thank you very much for your time and your presentation. So you sent me your slides. I'll save them as PDF and I'll post the slides with your permission on the Meetup site. On the Meetup site, there's for this event, there's a comment section. So I'll post a link there. And then if the audience wants to download the slides, they can do that. Okay. Are there any other ACM announcements? Anything else that anybody from the ACM group wants to bring up or mention? I will mention I am hiring a data scientist. I put it in the beginning of the chat. Senior data scientist that can be in Sunnyvale, California, or at any United States JCI office near you. I work at Johnson Controls now after an acquisition. So they're a large company with offices in many cities. And so please take a look at the link in the chat window or search Johnson Controls data scientist, Sunnyvale, California. And even though it can be any geography, that's an easy way to find it by search.
Hey, Greg.
Yes.
Did you already mention about upcoming ACM talks like from the science fair?
I didn't mention the science fair. If you want to bring that up, please go ahead.
Sure. So the Santa Clara Science and Engineering Fair is a huge science fair for middle school and high school students. It's about 1,000 kids. And our organization, San Francisco Bay ACM, judges those every year. We're one of many groups that judge for that. But we look for projects that have a computer science component, and we pick a first and second place and several honorable mentions in both the high school and another group in the middle school categories. Some of these have done really amazing work that where they write their own apps. They do good work in machine learning. A lot of things that you know, for me, I say, boy, it's amazing that these kids are doing this. And we have invited some of the top winners from that science fair to speak to our organization in some of these meetings like the one we're having tonight. So please keep looking at our meetup page, and in fact, join our meetup group so you will receive the notifications when we post the schedule for these meetings where these kids will talk about their projects and their experiences in doing the projects. Some of them had the good fortune to kind of have guidance from people in industry or people at leading universities. And in any case, they did very well. And we've done this for several years, and I think you will find it very interesting.
And just to be clear, you know, ACM focuses on the computer science component of the science fair. So they may be doing a physics project, but we would be judging the computer science component of that. So that's the focus of our ACM judging at the science fair.
Yeah, they might also be doing a medical project, but we focus on the computer science component. Yes.
Yeah.
Okay, thanks.
Thank you for bringing that up. Okay. Yeah, and then a number of people on the chat. Paul said, thanks, Boris, very interesting talk. Carl said, great talk. So I would say that as well too. Thank you very much, Boris. It's been a good presentation. I'm glad to have you back again. So if there's nothing else, we can close down the meeting, and we'll see the audience again in the future. Thank you.